Hello again. Let's talk about chemistry. And now we will start with the central part of chemistry, the atom. So, what is an atom? It is composed of mostly the neutron. I'll abbreviate it to N in most of my videos or video if I decide to not make any more videos. Protons, I'll abbreviate it to P, or maybe not Z. I'm going to abbreviate it to C, Z, Z, and electrons, where I'll abbreviate it to E minus. These are the core components of an atom, and what an atom is an atom is the building block of matter, I guess you can say. So uh I'll give you a visual stuff of an atom. So let's get this beautiful color. So this is going to be the nucleus, not to be confused with the nucleus of a cell. Nucleus is a word that describes center. I think the protons are going to be here. The neutrons are going to be here. The protons and neutrons are going to be here. So for neutrons, it's just these are the neutrons. These are the protons. Said, always forget. And electrons are somewhere outside. Somewhere outside. These are the electrons. So let's talk about concepts and intuition. All right. So let's look at our periodic table, and you see all the elements currently known to humanity. So let's look at hydrogen. Let's look at hydrogen. And what is the first number? What is oops, that's a bit too big, but who cares? What is this first number? This first number refers to its atomic number, refers to its atomic number. Atomic number. Well, to be more specific, uh, not really that specific, but atomic number also equates to proton number, proton, or Z for short, Z number, the number of protons. But why did I say specific? Well, one, because I'm dumb, and two, uh, in the olden days, atomic number, it wasn't just represented using the number of protons. Instead, it was it used to be represented with this second number. This second number is the atomic mass, the one that you find, the one that you're seeing, 1.00794 for hydrogen. So what is, I guess you can say, didn't we use why didn't we use this this atomic this atomic mass for the atomic number? Because someone corrected, I believe, Mendeleev was corrected by some other guy, some other brilliant guy, because he noticed, I think, not sure where it is. I don't remember. Don't remember which example it was. Oh, here, it's cobalt and nickel. You can see here that cobalt has a higher has a higher what has a higher um has a has a higher atomic mass than nickel, but its position in the periodic table is before nickel. So what that brilliant guy saw was there was a pattern that we shouldn't use atomic number. Instead, we should use proton number. So that's the pattern that he saw. I guess we should also introduce where does what how do you get the how do you get the atomic mass of an element, of an atom. What and what in what units are in what units are these atomic mass thingies. So let me encircle it again and zoom out, come here, and let's see. So what is 1.007 something? 1.007 something. In what units are these? What is a unit? A unit is a unit of measurement. A unit for mass. In the real world, we usually use kilograms, grams for our everyday use. In this context, of course, we could also use grams and or grams and or kilograms, but for for the ones in on the periodic table, this 1.007 is represented in atomic mass units, otherwise known as AMU. So what is the conversion between AMU and grams, kilograms, or grams? Well, I'm not gonna do that because it's kind of confusing. But you can say one atomic mass unit, one of one atomic mass unit. All right, one atomic mass unit is approximately the mass of the mass of a proton. The mass of a proton. This is the mass of a proton. I haven't used yellow. Mass of proton or neutron. They're approximately similar. No, not approximately. They're almost similar, but they're not similar. It's approximately it's approximately the mass of a proton. And what's the mass of a proton? If I could remember correctly, I think the mass of a proton is somewhere around 1.67. I'm gonna get more space. 1.67 times 10 raised to the negative 27 power. I'm assuming you know this notation. Otherwise, you should kind of review. And in what units? In the kilogram units, I believe. So. So in grams, it's going to be 1.67 times 10 raised to the negative 24 grams through its dimensional analysis in my head, in my head only. So it's so it's that. And why don't we count, or if it's 1.0 0.00794 atomic mass units, and I'm also assuming that you know that the hydrogen atom only has one proton, one proton, because the atomic number dictates the proton number. And I'm also assuming that you know that the proton number also dictates or is equal to the number of electrons for neutral for net new for non for neutral atoms, meaning they're not ions, so the number of electrons are equal. That means that a hydrogen atom has one proton, one electron. What about a neutron? What about a neutron? Let's get another color. What about a neutron? For a neutron, as you can see, it's 1.00794 atomic mass units, and since a neutron is approximately similar to the mass of a neutron is approximately similar to the mass of a proton, then that can only mean that there are no neutrons in a hydrogen atom. So what is the mass of the electron? What is the mass of electron? Assuming that you are a clever bastard, you might say, oh, then it's going to be 1.007 or 1.007 something minus 1, since one atomic mass unit is approximately is approximately one atomic mass unit is approximately one the mass of a proton. But yeah, it's kind of correct but not correct, because that one that 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 equation that I showed you is an approximation, so it's not completely accurate. And that means I'm going to show you what the mass of an electron is. It's very small compared to a proton and neutron. I believe it's 9.109. Get your drum rolls right now. Times 10 raised to the negative 31 power kilograms. That's very small. As you can see, that's very small. Whew. And see you in the next one.